Hey guys, welcome back to another video. This is topic 2.7, composition of functions. Consider the function f of x equals 2x minus 3. Evaluate the following. Starting with f of 5, I know that anything that's in the parentheses is basically an x value. So basically what we're doing is we're going to be replacing these two x values with the number inside of the parentheses. So instead of f of x, we'll have f of 5 is 2 times 5 minus 3, where 2 times 5 is 10, and 10 minus 3 is 7. So f of 5 is equal to 7. Okay. Next, we're going to do the same thing with c instead. So 2 times c minus 3. So f of c and 2 times c is just 2c minus 3. Those are not like terms, so I cannot simplify it any more than that. So that is the answer for f of c. Next, we have f of 4a. So again, I'm plugging in 4a in place of x. So we have 2 times 4a minus 3, where I can distribute the 2 inside. So f of 4a, 2 times 4 is 8a minus 3. And again, those are not like terms, so that would be my final answer. And the last one, we're going to insert all this, the whole binomial. So it'll be 2 times 5x minus 1 minus 3. And then I can distribute the 2 into both terms inside the parentheses. So now I have 10x minus 2 minus 3. And then I combine like terms. My like terms are these two numbers in the back because they don't contain an x. Okay, so now I have f of 5x minus 1 is equal to 10x minus 5. Okay, so that wasn't too bad. So basically, all we did again was everywhere that there was an x, I replaced it with the expression that was inside of the parentheses. And it could be something as simple as just a number, or a variable with a coefficient, or a binomial. Okay, so you can evaluate anything. And then if you're plugging in a number, you're going to get an answer that is a number. But if you have a variable, that variable is also going to appear in your final answer. Okay, so composite functions. Sometimes in math, we will plug a value for x into a function and then use that output, the answer, to plug into another function. When we plug an output y of one function back into a function, this is called a composite function. So example 1 says, let g of x equal 3x plus 1, and then let g of 2 equal c. Find g of c. Well, in order to find g of c, I first need to figure out what c is. And to figure out what c is, I first need to do g of 2. Okay? So in order to find c, I need to figure out what is g of 2. Now, g of 2, I'm going to plug it into this expression. Okay, so we're going to have 3 times 2 plus 1, where I'm replacing these two x's with the number 2. And this becomes 6 plus 1, so that means that c is 7. Okay, now I can go back and plug in this c value over here. So now we know that g of c is the same thing as just finding g of 7. Okay, and g of 7, I am again going to be plugging it into the expression for g. So that'll be 3 times 7 plus 1. Okay, so all I did was plug 7 in to this expression that was given to me for g of x. Okay, 3 times 7 is 21, and 21 plus 1 is 22. So g of c is 22, or g of 7. It is the same thing. Okay, so composite functions, there are two ways that we can write composite functions. The first one looks like it says fog, but it is a really small circle that just is a symbol for composition. So it could look like that, or it could be with all parentheses. Both of these expressions are read as f of g of x. So please, when you're reading this out loud, do not say f parentheses, g parentheses, x parentheses, parentheses. No, it is just f of g of x. Additionally, it's not always going to be in this order. I could do also g of f of x, or I can duplicate a letter. So I could do g of x, f of x. And it's not only two functions. I can compose 2 or 3 or 4 or 5 functions together. The limit does not exist of how many functions I can compose. So I can have f of g of h of x, or f of g of h of k of x. So I can do a bunch at the same time, okay? Now, an important note, when you're working with composite functions, you're going to start on the inside, okay? So it's whatever function is on the right side. So if you're given f of g of x, I see that the inside function, or the function on the right, is g of x. So I'm going to evaluate g of x first. And then whatever answer you get from g of x, you're going to plug it in to f of x. Okay, so you're kind of working backwards a little bit. Let's try an example. F of x is 3x minus 5 and g of x is 2x plus 1. Evaluate the following expressions. Okay, so I'm going to make f of x purple, and I'm going to make g of x in green. Okay, so they first want me to find g of 3 because that is the function on the inside. So to find g of 3, I'm going to do 2 times 3 plus 1, or 2 times 3 is 6, and 6 plus 1 is 7. Now that answer, I'm going to plug it into the outside function, which is f. So now I'm going to do f of 7, which would be 3 times 7 minus 5, where 3 times 7 is 21, and 21 minus 5 is 16. Okay, so my final answer here would be 16. So f of g of 3 is 16. Okay, let's do the next one. G of f of 3. F of 3 is the function on the inside, so I first need to do f of 3, which would be 3 times 3 minus 5. 3 times 3 is 9. 9 minus 5 is 4. Now that answer, they want me to plug it into the outside function, which is g. So I'm going to do g of 4, which is 2 times 4 plus 1. 2 times 4 is 8, and 8 plus 1 is 9. So g of f of 3 is 9. Next, we're going to do f of 4. So I'm going to first do f of 4 because it is the function on the inside, on the right-hand side. So that's 3 times 4 minus 5, which is 12 minus 5, which is 7. Now notice that this is a duplicate of f. So I'm going to do f again, but this time I'm going to plug in my previous answer, which was 7. So we're going to do 3 times 7 minus 5, which becomes 21 minus 5, which is 16. So f of 4 is 16. Okay, now remember I told you earlier, when you plug in a number, you're going to get an answer that is a number. So notice that all of our answers are numerical digits. That is not always going to be the case. So you can see in example 3, we're going to keep using the equations for f and g from example 2, and they want us to find the expressions for the following. So first we're going to do f of g of x. Okay. The inside function is g of x. Now I'm not plugging anything in, but I will write the equation for g of x, which is 2x plus 1. That whole expression, they want me to plug it into f. So we're going to do f of 2x plus 1. Let me color code this a little better. Hold on. 2x plus 1. So I'm putting the equation of g into the function of f. So that'll be 3 times 2x plus 1 and then minus 5. Okay, now I'm going to distribute this 3, which will give me 6x plus 3 minus 5. And then I combine like terms, which are 3 minus 5, which gives me negative 2. So f of g of x is 6x minus 2. Okay, let's do another one, g of f of x. Okay, the equation on the inside, the function inside is f of x, and f of x is 3x minus 5. They want me to plug that into g of x, so it'll be g of 3x minus 5. And the equation for g is 2x, but instead of x, I'm going to plug in 3x minus 5, and then we have plus 1. And I'm going to distribute this 2, which becomes 6x minus 10 plus 1. Combine your like terms, negative 10 plus 1 is negative 9. So g of f of x is 6x minus 9. Okay, so again, notice that when you are plugging in a value of x, you will have that same variable in your answer. Okay, so let's try some more examples. In example 4, given the functions above, find the following. So here we have h, k, p, and m. The first thing we're going to do is k of h of 2. Let me color coordinate these. So I'll make this one green. I'll make this one blue, purple, and then let's do pink. All right, so h of 2. I first need to find out what is h of 2. So we're going to do 2 times 2 minus 3, which is 4 minus 3, which is 1. Now I need to plug it into k. So we're going to do k of 1, which is 1 squared plus 4 times 1 plus 5. 1 squared is 1, 4 times 1 is 4, plus 5 equals 10. So k of h of 2 is 10. Okay, next we have b. If you want to rewrite this, you can. You can rewrite this in the other notation, which is you just do not switch up the letters. So if you want to write it like this, you can just kind of think of it as putting an extra set of parentheses instead of the little composition symbol. Some kids feel more comfortable with this notation, so you can always write it. Just again, remember to not switch up the letters. So if it's h first and then m, make sure you have h first and then m. Okay, so first I need to figure out what is m of negative 1. So m of negative 1 would be 3 times negative 1 plus 2, which becomes negative 3 plus 2, which equals negative 1. That m, I'm going to plug it into h. So we're going to have h of negative 1, which is 2 times negative 1 minus 3, which is negative 2 minus 3, which is negative 5. Okay, so h of m of negative 1 is negative 5. All right, last one, we have c, k of p of x. Again, if you want to rewrite this, you can do it in this notation. They are equivalent to each other. It's just a matter of preference. And so for p of x, we're not evaluating a number. This time we're going to be inserting the value of p. So p of x is the square root of 3x plus 1. And they want me to insert that into the function for k. So we're going to have k of the square root of 3x plus 1. Okay, which is, instead of x squared, we're going to have the square root of 3x plus 1 squared plus 4 times the square root of 3x plus 1 plus 5. Okay, so I just want to show you, they told me to plug all of that into k of x. I want to show you that these two circled in red are the same, except that instead of x, we have now plugged in the square root of 3x plus 1. but this was k of x is x squared plus 4x plus 5. Okay, just that those three x's are now replaced with the equation of p of x. So that p of x is going inside of all the variables that used to be x. Okay, and now we are going to simplify. So with the first term, I know that a square root and a square always cancel, so these cancel out. So I'm left with 3x plus 1. Now these I cannot multiply, I cannot distribute this into the square root, because if you follow PEMDAS, let's say just for example x is 2 and you plug in 2, you would first do 4 times the square root of 6 plus 1, and then you would do 4 times the square root of 7, and then you would figure out what the square root of 7 is, and then finally you would multiply it by 4. So the very last step is to distribute that 4 on the outside. You first have to do everything that is on inside the parentheses because PEMDAS says parentheses first. So for this one, you would not be able to simplify it. Even though it looks ugly and weird, you would just leave it like that. And then we still have the plus 5 that was added in the end. And then notice that these over here are like terms, the 1 and the 5. So these two here, I'm going to add those together. So we end up with k of p of x is 3x plus 6 plus 4 times the square root of 3x plus 1. Okay. So far we've done equations. You're not going to do composition only with equations. You can also use graphs and tables and piecewise function and all of these. So that's what example 5 is going to show you. The graph of the function f of x is given above along with a table of selected values for the function g of x, an equation of the piecewise function h of x, and a verbal description of the function k of x. Use this information to evaluate the following if possible. Okay, so notice that there's 4 different equations, so you got to make sure you're looking at the right one. So this is for f, this one is g, this one is h of x, and then this one is k of x. So when you're looking at the options, you need to make sure you're looking at the right one. Okay, so first we're going to do a, which says f of g of 3. So I need to do the inside function first, which is g of 3. Now remember, this 3 represents your x value. So they're telling you what is the y value on the table of g when x equals 3. So I'm looking here at the table of g. I do not see x equals 3. Now, they added if possible. So that means that you're not always going to be able to compose the functions. So because g of 3 is not defined, that means that f of g of 3 is not possible. And so you would just say it is not possible. Okay, let's do h of f of 8. Again, if you would like to rewrite this as h of f of 8 using this notation, you can. So f of 8, I first need to evaluate the inside. So remember, this is an x value. They're saying when x equals 8. So I'm going to go to the graph of f. I'm going to find where x equals 8. Notice that there's no points here, but if I go down, there is a coordinate at negative 1. So 8, negative 1. When x is 8, y is negative 1. So f of 8 is negative 1. Next, I'm going to find h of negative 1. Now, h is over here. Now, the thing with piecewise functions is that you have 3 different types. It doesn't have to be 3. It could be 2, 3, 4, 5. It doesn't matter. But each of the different subfunctions is going to have their own domain. So this absolute value function only works for the x values that are less than 1. This negative 4 only works when x is exactly equal to 1. And the function negative x will only work for the x values that are greater than 1. So here I'm evaluating x equals negative 1 which is a value that is less than 1. Okay, so that means I'm going to use the first equation. So this domain includes x equals -1, which is what we're looking for. So for that reason, I'm going to use the absolute value and not any of the others. So -7 plus 3 times -1, parentheses first, -7 minus 3 becomes the absolute value of -10. And anything inside the absolute value always becomes positive, so it will be positive 10. So h of f of 8 is positive 10. Moving on to C, we're going to do g of k of 0. Again, if you would like to rewrite that, you could do g of k of 0. First, we're going to do k of 0 because it's on the inside. Now the equation for k is written out. It says k of x is a quadratic function with a horizontal translation of 2 followed by a vertical translation of -3. So to do this one, you need to be familiar with the parent function of a quadratic. And the parent function of a quadratic is x squared. That's the most basic quadratic function you're going to get. Okay, you also need to be familiar with the transformation equation that we learned in 1.12. So for transformations, you have a times b times x minus h and then plus k, where a is your vertical dilation, b is your horizontal dilation, h is your horizontal translation, and k is your vertical translation. So you need to be familiar with that as well, because you need to put this in order where it wants it. Okay, so again, vertical dilations are multiplied on the outside. Horizontal dilations are multiplied inside the parentheses. Horizontal translations are added or subtracted inside the parentheses, and vertical translations are added or subtracted outside of the parentheses. So all of your horizontal transformations occur inside the parentheses with x, and all your vertical transformations occur outside of the parentheses. Okay, so for k of x, I don't have an a and I don't have a b because they didn't tell me I have any dilations. So I can go straight in, start my parentheses with x, and we have a horizontal translation of 2. Now this is a positive 2, and remember that everything inside is always the opposite. So instead of saying plus 2, I'm going to say minus 2. And then because this was quadratic, I am going to be making this squared. So if this had been cubic, I would just put a 3 on the outside. Or if it had been a quartic, I would put 4 on the as the exponent. Or if it was linear and the exponent is 1, I would just put 1. Or I could just omit it because anything to the power of 1 is whatever you have anyway. And then a vertical translation of -3, and everything on the outside is exactly as it appears, so that will be a -3 on the outside. So now that I have the equation, I can plug in 0. So I'm going to have 0 minus 2 squared minus 3. You got to do the parentheses first. 0 minus 2 is -2 squared minus 3. -2 squared is positive 4, and 4 minus 3 is 1. Next, I need to find g. So we're going to do g of positive 1. So I'm going to go to my table for g. I'm looking for where x is positive 1, and I do not see it. So g of 1 is not defined because it is not an x value on the table of g, which means that g of k of 0 is not possible. Okay, let's try letter D, f of 2. Starting with the inside function, which is f of 2, Remember that x equals 2, so I'm going to go to the graph where x equals 2. Now, notice that at 2, there are 2 points, but one of them is open and one of them is closed. When you're given the option, you always have to pick the one that is closed. So when x is 2, y is 1, okay? So open circles are undefined. So you're never going to pick those. There's basically nothing there. It's not existent. They're just showing you that it's undefined there. Okay? So f of 2 is positive 1. And f was duplicated, so we're going to plug it back into f, but this time we're going to find f of 1. So when x is 1, the y value is positive 4. So f of 1 is 4. So f of 2 is positive 4. Okay, next we're going to do g of h of 1. So starting with h of 1. So I'm going to go to the piecewise, which is h, and I'm looking for where x equals 1. I see that's in the middle. So this one includes x equals 1. And the equation is not even an equation, it's just a number. It is negative 4. So h of 1 is negative 4. Next, I'm going to go to the table of g, and I'm going to find g of negative 4. So when x is negative 4, the y value is pi. So g of negative 4 is pi. So g of h of 1 is pi. Okay. Last one, we have g of f of h of k of 3. If you would like to write this out using the other notation, you can write it out like this, and you first have to do k of 3. So k was x minus 2, but we're going to do 3 minus 2 squared minus 3. Starting with the parentheses, 3 minus 2 is 1 squared minus 3. 1 squared is 1, and 1 minus 3 is negative 2. Now that I'm done with k, I can move on to h. And h of negative 2, we have to select the correct one. Negative 2 is less than 1. So we're going to use the absolute value again because this one also includes x equals negative 2. So we're going to do the absolute value of negative 7 plus 3 times negative 2. We're going to multiply, and we get negative 6, which is negative 13, which becomes positive 13. Everything that's the absolute value is always positive. So now that we've done h, I can move on to f. So f of 13. So now I'm going to go to the graph of f and find x is equal to 13. But I run into a problem because my biggest x value is 10, and they're asking me about 13, which I can't see on this graph because they stopped it at 10. So this one is not defined. It doesn't mean it doesn't exist. There could be something there, but they didn't show it to us. So that means that g of f of h of k of 3 is not possible. Okay. And that is it for today's notes. Now, when you guys are working on your homework, you will find that some of the problems are going to require you to use the property of exponents. So I would recommend having your 2.4 notes out. Just as a refresher, you will be using the power property, product property, negative exponent property to simplify some of these. So the concept it's pretty easy, it's pretty self-explanatory. the problem is going to be simplifying things that are exponential. So if you guys have any questions, let me know in the comments below, and please subscribe to my channel, and I will see you in the next video. Bye.